So in today's lesson, we are going to do the exact same thing we did yesterday, except our equations are going to be a little bit harder to put into slope-intercept form. So we're going to have to practice some of our algebra skills. All right, since we're doing the same process, they're the exact same steps. We've got to get our equations in slope-intercept form. So I'm going to start with my red equation by subtracting 2x from both sides. This one is already solved for y, so I'm going to start to graph it. On my y-axis, I'm going to go up 8. My slope is -2, so I'm going to fall 2 and run to the right 1. Or up 2 and left 1. As a reminder, we want to make sure we use the entire graph because we have no idea where our lines might intersect. Second equation, I'm going to start by adding x to both sides. So I have 2y equals x plus 1. To solve for y, I'm going to divide everything by 2. So I've got y equals, my slope is 1/2. If you're not sure where that 1/2 came from, remember anytime you see an x all by itself, it's really being multiplied by a 1. So I just kind of pulled a 1 out so we can see the slope a little bit easier. And my y-intercept is 1/2, so that's going to make it a little bit harder to graph. But we're going to go up 1/2 on our y-axis. And then instead of using the slope as rise 1 and run 2, I'm going to go up 1/2 and over 1. And then I'm going to start my rise over run because now I've got nice coordinates and it meets my red line at a nice coordinate now. And we can also go the other way as well, just to use our whole graph and get in the practice of it. Alright, so we find that ordered pair where the graphs meet, and in this case, looks like it is at 3, 2. So that is I'm going to go ahead and classify the system right now. That is my one solution. Because it has a solution, it is consistent. Because it's got 1, it is independent. Alright, now I'm going to check to make sure the solution I found really works. So in my original equation, that's really important because you may have made a mistake solving for y, or you may have made a mistake graphing. So use your original equation to make sure that you found the true solution. So substituting 3 for x into my red equation, and 2 for y, we check to see if it works. 2 times 3 is 6. 6 plus 2 is 8. So my red equation checks out. Using my blue equation, same process. Substituting 3 for x and 2 for y. Does it equal 1? Well, 3 times a negative is negative. 2 times 2 is 4. And -3 plus 1 is 4. So it checks out.